My name is Prasananjaneyulu. I am the Associate Professor of Mathematics in the Department of Mathematics in CMR College of Engineering and Technology. Okay, and my concept is I am going to discuss about the vector identities in vector calculus. For that, in the previous lecture, I already discussed about vector differential operators and scalar differential operators, vector differential operators, Laplacian operator, and the first vector identity is divergent of phi a bar, as well as discussed about curl of phi a bar. Okay, now in this lecture I am going to discuss about the third vector identity. Okay, so now here the third vector identity is prove that gradient of a bar cross b bar is equals to, okay, b bar dot del of a bar plus a bar dot del into b bar plus b bar cross curl a bar plus a bar cross curl b bar. Okay, so for proving this one, I am going to start with I'll take the fourth term of the right hand side part. Okay, so take a bar cross of curl of b bar equals to, what is curl of b bar? Del cross b bar. So writing it is in the form of a bar cross of del cross b bar. Now I'm going to write this one in the form of summation, not the total thing. I'm going to write as a summation. I'll take only the post factor. What is the post factor? Del cross of a bar. I'll write it is in the form of summation. So a bar cross inside the brackets, del cross a bar can be written as a summation I bar cross dou b bar by dou x. So as we discussed earlier already, then what we are going to, how to write the del as a summation, wherever del is available, we have to keep I bar and the post factor will get dou by dou x. Now, if you expand the summation, then what we are going to get, I bar cross dou b bar by dou x plus j bar cross dou b bar by dou y plus k bar cross dou b bar by dou z. All the three terms are having a bar cross is common. So using the left distributive law, then what this summation is going to become as a summation, this a bar can be taken to inside. So that means I bar is a vector, dou b bar by dou x is a vector. I bar is a vector, dou b bar by dou x is a vector. Cross product of two vectors is also a vector. Okay, this vector, if we have observe like we are having, so here giving explanation, we are having like a bar cross g bar, otherwise f bar plus g bar plus h bar is there. Then how we can write this is as a bar cross f bar plus a bar cross g bar plus a bar cross h bar. So using the left distributive law, I am going to write this is as, this is as summation, okay, a bar cross I bar cross dou b bar by dou x, right? Summation is there. In the rough work, I mentioned as some part how to write it is, okay, but the three terms f, g, h is in the form of summation in our case. Okay, now you already know that a formula of intermediate concept. So a bar cross b bar cross c bar. What is the a bar cross of b bar cross c bar? A bar dot c bar into b bar minus a bar dot b bar into c bar. So using this formula, I'm going to write inside the summation as, how we can write inside the summation as, this summation is going to become like a bar dot dou b bar by dou x into I bar minus a bar dot I bar into dou b bar by dou x. Both the terms are having summation. Now I will separate the summation. Okay, I will separate the summation. Then if we separate the summation, then the first term is going to become summation a bar dot dou b bar by dou x into I bar minus summation a bar dot I bar into dou b bar by dou x. Right? Now, if we observe the first term, I'm going to write like this. For example, a bar dot dou b bar by dou x. A bar is a vector, dou b bar by dou x is a vector. Okay, which term? The first term. A bar is a vector, dou b bar by dou x is a vector. Dot product of two vectors is a scalar. This scalar can be multiplied with a vector I bar. Okay, nothing but here I'm going to take so 3 into I bar is there. This 3 into I bar also can be written as I into 3 bar. So using this way, okay, that means our vector and scalar can be multiplied in pre and post manner in any manner. So that I am writing the first term as summation I bar into a bar dot dou b bar by dou x. This is the first term. And the second term will be as it is. And the second term I'm going to write as like this. So observe here carefully. The summation contains I bar. Wherever I bar is there, the post factor contains dou by dou x. So I'm going to remove the summation. How I can write when we want to remove the summation? Okay, in place of I bar, we will simply write the del, because the post factor also contains dou by dou x. So how we can write the second term as del? A bar dot del of b bar, or a bar dot del into b bar. So this everything is a bar cross curl of b bar. Okay, now I'm going to keep this one in the box. What I'm going to do is, okay, this we took initially and did it. Similarly, what I can get b bar cross curl a bar. That means in place of a bar, I'm going to take b bar. In place of b bar, I'm going to take a bar. That means swapping a bar and b bar. So in the above equation, I'll replace a bar with b bar with a bar. That is a swapping. Okay, then what is the first term is going to become? If we do in the same manner, we are going to get summation I bar into b bar dot dou a bar by dou x minus b bar dot del of a bar. So this is the first term, putting brackets. Okay, taking as equation number 1 and 2. What I am going to do is, I will add 1 and 2. I am going to add 1 and 2. So add 1 and 2. That is a take 1 plus 2. That implies, what is LHS part is going to become a bar cross curl b bar plus b bar cross curl a bar equals to, what is the first two terms of RHS? I am adding them, and at a stretch I am writing. So summation I bar into a bar dot dou b bar by dou x plus summation I bar into b bar dot dou a bar by dou x. Okay, first terms of equation 1 and 2 of the right hand side part. Same manner, at a stretch, I am writing the second terms of the first and second equations I am writing here. So it will become minus a bar dot del of b bar minus b bar dot del of a bar. Okay, then what I am going to do is, in the next step, the right hand side last two terms, minus a bar dot del into b bar minus b bar dot del into a bar, that everything I'll bring it to left side. Then what it is going to become? I'll bring the last two terms of RHS part, that is a third and fourth term to left side. What is the LHS part is going to become? LHS is going to become as a bar cross curl b bar plus B bar cross curl A bar. The right hand side is containing negative sign. So bringing to left side, it will become positive. Plus A bar dot del of B bar plus B bar dot del of A bar equals to. Then observe the first and second term of RHS part. That means these two terms. If we observe these two terms, we can take summation common. That is one point. The other point is I bar is also common. Okay. So now writing the RHS part, the remaining two terms as summation, I bar is also common. What is the remaining two terms? A bar dot dou B bar by dou X plus B bar dot dou A bar by dou X. B bar dot dou A bar by dou X, dot product will satisfy the commutative property, that is A bar dot B bar can be written as B bar dot A bar. Same manner, B bar dot dou A bar by dou X can be written as dou A bar by dou X dot B bar. It is not a problem at all if we change them, the last term of right side part. Then what is the RHS part is going to become? Summation I bar into. How it looks like? U A bar dot dou B bar by dou X plus dou A bar by dou X dot B bar is nothing but, it is in the form of it can be written in the form of differentiation of UV. That is dou by dou X of U and V are A bar and B bar. There is a dot product in between them. So this is the thing. Next, summation I bar into dou by dou X of A bar dot B bar. Summation I bar into dou by dou X of A bar dot B bar. A bar dot B bar is a A bar is a vector, B bar is a vector. Dot product of two vectors is a scalar. So treat it is as a phi. So summation I bar into dou phi by dou X can be written as removing the summation. So del of phi. What is the phi is here? Del of A bar dot B bar. But del of phi, another name of del of phi is nothing but grade of phi. Nothing but grade of A bar dot B bar. And rearranging the left hand side part in the given order. So I am writing, okay, A bar dot what is the first term in the proof? B bar dot del of A bar. So writing this as first term. Next, plus A bar dot del of B bar. Writing this as second term. Next, B bar cross curl A bar. Writing this as a third term. And then A bar cross curl of B bar. Writing this one as a fourth term. That means in the reverse order we are writing. Then what it's going to become? The LHS part. So B bar dot del of A bar plus A bar dot del of B bar plus B bar cross curl of A bar plus A bar cross curl of B bar. Okay, so which is equals to gradient of A bar dot B bar. Hence proved the property. Okay, so this is our third property. Same manner, I'll go to the next property now. Now, the next vector identity is the fourth one. Here, prove that, okay, curl of A bar cross B bar equals to A bar into divergent of B bar minus B bar into divergent of A bar plus B bar dot del of A bar minus A bar dot del of B bar. This we have to prove. For proving this, I am going to take a LHS part. LHS part is a curl of A bar cross B bar equals. How we can write a curl of A bar cross B bar in the form of del. So del cross of A bar cross B bar. Del cross of A bar cross B bar. How we can write del cross of A bar cross B bar in the form of summation? Del of I bar cross dou by dou X of A bar cross B bar. But the dou by dou X of A bar cross B bar. A bar is in terms of X, B bar is also in terms of X. Then their product is in terms of X. So Dou by dou x of a bar cross b bar is in the form of differentiation of uv form. Then how we can write the differentiation of uv as u into v dash, that is a bar cross dou b bar by dou x is the first term, plus u into v dash plus u dash into v. What is the u dash here? Dou a bar by dou x cross b bar. This is the thing we are writing. Now here I am going to write a bar is a vector, dou b bar by dou x is a vector. Cross product of these two vectors is a vector. So assuming this is as a f bar, nothing but I bar cross, so first term treat as f bar, plus second term dou a bar by dou x is a vector, b bar is a vector, cross product of two vectors is a vector, so treating this as a g bar. Then using the left distributive law, how we can write? Both the terms can be multiplied with the I bar with cross product. So it can be written as I bar cross f bar plus I bar cross z bar. So using this basic formula, we are going to write it is as two terms, and both the terms will be getting the summation. So summation I bar cross a bar cross dou b bar by dou x plus, this is the first term, and the second term plus summation of I bar cross dou a bar by dou x cross b bar. Okay, this is the second term. Now, as we discussed in the previous property, a formula we used, that is a basic formula. So a bar cross of b bar cross c bar. What is a bar cross of b bar cross c bar? A bar dot c bar into b bar minus a bar cross b bar into c bar. So using this formula and expanding both the terms in the right hand side part. So what is the first term is going to get? First term will get, okay, I may not get the sufficient space there, so I am moving the things into the left side. Curl of a bar cross b bar equals to, what is the right side part? First term is going to become as a summation. The first term I bar dot dou b bar by dou x into a bar minus I bar dot a bar into dou b bar by dou x. This everything is using the right side, which I discussed the formula a bar cross of b bar cross c bar. Okay, plus what about the second term in the right side is going to get summation of, again it is in the form of a bar cross of b bar cross c bar. So how we can write this is as a I bar dot b bar into dou a bar by dou x minus I bar dot dou a bar by dou x into b bar. Okay, so now I will remove the brackets, and for all the terms summation will get. That means first two terms containing a common summation, last two terms containing the common summation. I am removing the brackets and that summation will get for each and every term. But while writing that, I am going to write here it is as, okay, so the first term is going to get summation I bar dot dou b bar by dou x into a bar minus the second term summation, while writing this I bar dot a bar as, writing as a bar dot I bar. Why I am writing is, I want to write the summation as a del. So when I can remove the summation to write it is in the form of del, wherever I is available, the post factor should contain dou by dou x, but we are not having dou by dou x here. We are having the dou by dou x here. So how I can, we cannot get dou b bar by dou x into the previous factor as a previous factor, prefactor. So I am interchanging I bar dot a bar as a bar dot I bar. So it is acceptable and we can write it is as like that. So I written a bar dot, okay, I bar dot a bar as a bar dot I bar into dou b bar by dou x. By writing like this, then wherever I bar is there, the post factor contains dou by dou x. So I want to remove the summation, then easily I can write del in place of I bar plus what is the last two terms when we separate as a summation. Here also same, I bar dot b bar into dou a bar by dou x can be written as b bar dot I bar into dou a bar by dou x minus summation. The last term is going to get like this, summation I bar dot dou a bar by dou x into b bar. Now all the terms I am writing them in the form of a summation, okay, del. I am removing the summation. So this is the first term, this is the second term, and this is the third term, and this is the fourth term. Okay, now I want to remove summation, writing in the form of del. So now wherever I bar is there in the first term, the post factor contains dou by dou x. So if I want to remove the summation, then I can write this one as del dot b bar into a bar minus the second term can be written as a bar dot del into b bar. Okay, next plus summation b bar dot I bar into dou a bar by dou x can be written as, okay, b bar dot del into, okay, a bar minus the last term can be written as summation I bar dot dou a bar by dou x into b bar can be written as del dot a bar of b bar, and writing this is as a first term. Which one? The first term as it is first term. Otherwise, I'll write first del dot b bar. Del dot f bar is nothing but divergent of f bar, so it can be written as divergent of b bar. Divergent of b bar into a bar or a bar into divergent of b bar. Both are same. Minus. There is no change here. I'm writing as is a bar dot del of b bar plus b bar dot del of a bar minus del dot a bar is nothing but divergent of a bar, but divergent of a bar into b bar also can be written as b bar into divergent of a bar. The reason is why I am writing is here. I am explaining for the last term. Del is a vector. So I am explaining for the last term. Same manner it is applicable for first term also. Del is a vector. A bar is a vector. Dot product of two vectors is a scalar. So nothing but I can write here phi into b bar or b bar into phi. Both are same. So this is applicable whenever one is a vector, another one is a scalar. Okay. So now going to rearranging the terms in our required order. Okay. First, what I am going to do is I'll write this is as a first term. First term as first one. But the last term I am going to write as second term. Okay. Last but one term going to write as third term. And this is second term is going to write as fourth term in our particular order. Okay. To get to show what we have to do. So a bar into divergent of b bar. What is the second term we have to write? Last term minus b bar into divergent of a bar. Okay, plus third term, writing as the third term only, b bar dot del of a bar minus a bar dot del of b bar. So which value is this one? Curl of a bar cross b bar. So this is the one we required to prove, hence proved. Check whatever the statement we want to prove. We got it. Oh, hence proved. Okay. With this, I'm stopping this lecture. In the next lecture, I'll discuss about the next property.